Good morning. I didn't quite finish the C++ port checks yesterday. There was one bug left. I want to fix that right now. I want to get a version of this C++ puffer working. That's pretty much it. I'm not streaming all day. I'm going to do a couple hours maybe. And we're going to go from there. All right. Get rid of this chat window. Yeah, there we are. Okay, so where we left off here, I had this almost working. But there's like a 6th or 7th digit mismatch between these. That's what we're gonna figure out. 6th or 7th digit mismatches. And I guess I really just have to like match exactly, right? Yeah, I just gotta match these like perfectly. Welcome, alien. Okay. Yeah, so I think I'm just gonna start by doing something silly. Take this. Wait, hang on. Maybe I might be doing something silly here. Let me just run this again. And we'll see. So the issue at the moment is we have like a very, very small mismatch between the policy gradient losses. Let me see where. Actually, let's put this over here. While we look at this policy gradient loss. Yeah, so you see like right over here, it's like all the way down here is a mismatch. And it shouldn't be any mismatch because it should be the identical functions. Okay, so entropy is the same. Logits. The same. Yeah, let's just get some more prints in here. Just get some more prints in here. I've gotten some pretty good runs in the last couple of days. I still have to sync my watch to see by how much, but got a really big 1 mile PR. Other than that, I've just kind of been working on this port bit by bit. This is my opinion. Why are there no good tutorials how to create a new env? I had to ask in Discord how to do this. What? Yo, Opus. Did you check? I have 2 docs. Okay, I want to know if you read these first. And if you did read these, then I want to ask, like, exactly what you didn't find helpful, because it would be good feedback. But if you didn't read these, then you should have read these first. So we have, in the docs, there's only one tutorial. It's writing your own 1 million plus step per second environment. This is a very short tutorial, but it links to source code. And it links to source code for everything. That's very well commented. And it tells you how to do everything. And then for higher level stuff, which is a lot more in like RL in general. Damn it, let me get my my logged in tab. The one is, did you read that? And then the second one is, did you read the intro article that I always link everybody to? If you read both of those and actually went through them and are still confused, I'd very much like to know what I can do better. All right, let's see where we were here. All right, we were editing this up. I skipped the first one. Wait, you skipped? If you skip the dude, look, if you skip the tutorial that's literally labeled, I spent time on this, man. If you skip the tutorial that literally says writing your own million plus step per second environment, then I can't help you, because this is the information you're looking for. Like, I spent a lot of time on this. There are 2 separate tutorials in here, man. There's the squared environment, which is a simple single agent one, and then there's also commented code for target. And we even have a template environment here where you can copy paste this and use it as a starting point. So like, I put all this information. This is literally like less than 2 pages to read. So I get a lot of questions on this, but I don't know what I can do better here if it's like, if people don't read this. Now look, if you read this and tell me that you're still confused, that's another story. But you gotta at least read the docs page. There's really not that much like stuff to read through, right? Disadvantage here. Wait, hang on, let me see. The titles are confusing. You have to know that you're referring with the title to an env. But it's fine, thank you, I'm good now. Wait, actually that could be good feedback, hang on. So wait, help me actually help me understand. Like, this is environment. Like, is it not clear that env stands for environment? Because my intention with this, right, was to provide a little bit about the library, and then the one actually important tutorial that everybody wants here. And then there are a whole bunch of examples here, right? We have a whole bunch of links to examples. I get a lot of questions about the docs. So, like, I want to improve them. What is SPS? Ah, okay, I get it. Gotcha. Cool. See? That is the useful information. Super Maven, man. It's a really dumb language model, but it runs really fast. Saves typing, not thinking. Is this better? Opus, is this clear? Try my own implementation. How to play with PufferLib? How to play with PufferLib. So the thing that's a little tough about how to play with PufferLib is it's kind of just on me to make it as simple as possible. Awesome, thank you. Okay, cool. Is this clearer to everybody? Writing your own environment 1 mil steps per second, SPS steps per second per core. This should eliminate a lot of questions. We're going to do even better for you so that people don't miss the template. All right. Okay, cool. Hang on. I'll answer questions in a second. Let me merge this. Cool. All right. I watched your iceberg video today. It's great explaining what Puffer does. Better. You should link it. Yeah, I don't know what happened with the iceberg video. I put a ton of work into that. And It really didn't get very much attention. Like, I reposted a few times, really didn't get much attention. Super Maven was acquired by Cursor and never updated. Yeah, which is shit. Fuck Cursor is my view on that. Don't use it. I like single line tab completion that like doesn't. I actually wish I could disable multi-line on this entirely so that it stops trying to fuck with my code. Like, I want this thing to be LSP++. I don't want this thing to try to think for me. Start in the docs. Okay, I can do that, mechanics. You know, I kind of want to, like, wait a bit, though, on that. Like, I kind of want to just at some point go through and... Well, I need at some point to, like, actually reformat my guide and put it on... Because I have my guide on the website as well. But, like, it didn't format nicely. Yeah, some of these just didn't format nicely. And I need to put a few more things on here. Let me see. Is the iceberg video really that? I guess I can. I can actually put it. That's a good idea. So there's this video if you haven't seen it. Off Paul with negative. Times it works better. It's just obnoxiously low data regime stuff, Tim. And actually, SAC is, like, not even good at all. Yeah, tab 9 was the other one. I think this one was better from what I've seen. I haven't played with it, though. Thesis. That's too much material, mechanics. The Puffer white paper isn't the Puffer white paper there? Or did I not? Yeah, it's here. Oh, it needs a link, but yeah. Oh, no, it's there. But, like, it's the old one, because I tried to upload the Puffer paper, and I got, like, stupid archive moderators tried to, like, because of overlap with the original. MJX, Fan Kyung. Yeah, you can use Puffer with whatever. You can use Puffer with whatever. Yeah. So honestly, Savesh, you're gonna see me using a decent amount of LLM stuff today, because I'm dealing with the Torch C++. But, like, basically the reason for that is I'm not familiar with the Torch C++ backend, and it sucks. Like, the way forward is not to make shitty libraries with bad docs and then rely on LLMs. It's to make good libraries with good docs and use your brain. And, like, obviously that's harder, so yeah, we lean in the direction of everything just getting more shit over time, but that doesn't mean we shouldn't push back against it. SAC base work with PPO base. I cannot for the life of me. Yeah, Tim, I actually tried to implement SAC on stream with Puffer, and it just was shit. I think it's just a bad algorithm, honestly. I don't even see how they're remotely, like, comparable at all. SAC has a really shitty credit assignment metric, and, like, the max entropy formulation is frankly just stupid. Like, the only environments that should work for are really shitty environments. Oh, where's this? Right, I said I was gonna link this. Why is this not complete? And I gotta get the link. LMs. So I've tried several of them. The thing is, they all suck. Like, they just all suck. Like, they swear these things are just architecturally stupid. And actually, I don't want to try ChatGPT. The latest thing that I've been using, which I think is the best if you have to use something, is the Cerebrus front end, purely for the reason that it is the fastest inference. What's really, really bad is sitting and waiting for 2 minutes while the LLM spits out a response. There we go. Added to what the website as requested. Random force DQN with PufferLib, solve it better. Yes, we've done multiple like contracted projects in that area. We're not finance specialists by any means, but we do general purpose reinforcement learning work, and that is one of the areas that we do work in. No, not Monte Carlo. I'm not going to give you details of that other than just to say that, like, we build a finance end like we would build the other puffer ends. It's essentially we build domain-specific high-performance sims, and then PufferLib is just really, really good RL. So, a lot of projects that you would just spend months and months on, Puffer will just nail out of the box if you know how to build the sim right. Welcome, Tim. Okay. Done with this. I'll give myself an hour or so to digest before we start on heavy deadlifts. C++ port is going fairly well. This is what we're working on today. There's one last discrepancy where we have something is mismatching in like the 7th digit of the loss. And I have to figure out why. There's some very minor mismatch. And I need the C++ and the Python not to be very close. I need them to be identical because this is going to be the test that I use going forward to maintain multiple backends. Since the engine underlying is the same, the numeric should always be identical. So this essentially means that I can have 2 backends to PufferLib and assert they're identical and never have any conflicts. That's the goal. So let's see what we were doing with this. We would do Python. Okay. We good? Because the Torch API is C++, I would gladly use C if they had it. Actually, the reason I didn't do this before is because the C++ API sucks. but it's what we have. Rust is a stupid language. C++ is a stupid language that's bolted onto a very good language. So at least in C++, I can just not use the stupid things and write stuff that's as close to C as possible. And I'm going to fight the Torch API to make the implementation better. Morning, Jess. Mm. I'm sit when I was a freshman, learned fully LLM coding. Advice for detoxing. Yeah, man, just write some of your own stuff. Like, do some of your own projects and, like, actually think carefully about what you're typing, right? Go build a puffer end. And go build a little game. Make it fast, very simple code. You'll see how much simpler it is. If you go look at some of the handwritten code we have versus the crap that LLMs will output, like, it's just so much simpler. What do you use Torch for? Training? Like the neural nets? What do you mean, what do I use Torch for? Yes, I have my implementation of the training algorithm in Torch, right? What, did you think that I wrote my own? Like, I don't have my own kernels, man, for every single layer. I do have a version of Torch that I wrote, that is inference only and very slow that we use for demos because it compiles to WebAssembly, but you wouldn't use it for training. Yeah, don't vibe code shit. I thought you had your kernels. I have an advantage kernel. We have like one kernel for an op that we need, but we don't have like, we don't have our entire own like training engine, right? If I had a training engine to puffer quality, like, that's what I would be working on full time, and I would be trying to like, replace PyTorch and Jax and all that. Dr. J, how's Puffer going? Puffer's going well. Current goal is C++ trainer, and I want Puffer 4.0 to be 10 million steps a second. That's the target. 10 million step per second training. C++ will get us up to 5 million. Alternative alternative RNN formulation, if it works, will get us to 7 or 8, and then 16-bit training will get us over 10. That's the goal. Welcome everyone on YouTube. Okay, let me see where this mismatches. So here's our advantage. New advantage. Ooh, something's weird here, right? Are there simpler, faster training engines? There are simpler ones. Well, there's one simpler one, TinyGrad, but not faster. What device is that benchmark on? The target will be a 5090 for that. 4090 would be even better. We might be able to hit it on a 4090. I wouldn't be surprised. Oh, and also it's for not a stupidly tiny network. Like, that will be for at least 128 hidden dim net with memory, not like a 32 two-layer thing. There are a couple libraries out there that claim to be faster than Puffer, but then they use like really stupid tiny networks. So nobody outpuffs the puff. What did I print here that's different? So this is MB Advantage. 3. Okay, so this is the same. And then what's this new advantage? Ah, here it is. So 7, 9, 4, 8, 2, 9, 9. This looks the same to me, man. So wait. Update on chess was still having that change. Draw, collapse, went through my move code. As the league move penalties were being abused. We work towards to mathematically ensure everything's normalized. Currently training on that. Cool. Chess will be an awesome EV, Jess. I'm looking forward to that. I wish I could pull up my Strava real quick. I had something kind of cool yesterday. I didn't have time to run in the morning, and I only had like 20 minutes to go out before dinner. So I said, screw it. I'm going to do a 1 mile warm up, and then I'm going to do a fast mile. I think my best mile ever before this, at least like since high school when I was super light, was like a 7:0. I don't know, like a low 7, right? Uh, and I ran like the slowest that mile I just ran. I haven't actually gone and checked the logs. The slowest it could have been was 6:34. So I was pretty happy with that. Gotta keep in shape when you just work on code all day. So, repping double body weight deadlifts, 6:30 pace mile. I'm pretty happy with the progress. I'll do some deadlifts in a bit today as well. Physical translates to mental. Okay, so this is actually a little bit of a subtle point with research. Research requires an incredible amount of mental discipline, and it's like inherently a volatile area where you're going to make a ton of progress at some time and not a ton of progress at other times, and it's very demotivating. And you're also not always going to have the mental. You're not always going to be in the right mind state to do your research. So having discipline consistently in another area of your life where you kind of prove to yourself, right, that you are capable of putting in that level of effort and of like chipping away at hard things, it lets you, when you're having a low in your research, it lets you just say, you know what, I'm going to take off, I'm going to reset, I'm going to come back, and I'm going to trust that I have the discipline to do that, right? Because I've proven it to myself. Very, very important to have that. Without that counterbalance, research is incredibly, incredibly depressing. Out to dinner? No, no. I typically have dinner at like a pretty precise time, is all. And it's not that remote either. If I do want to go out to dinner, it's like a 15-minute trip into town. Like 6 miles is the nearest. It's still remote enough, there's no light pollution pretty much. Like completely dark at night, no noise other than like wind. Very peaceful. Really, really great for clear thinking. I feel so much better here than in California. California's great for business, but it's like it's so nice here. Yeah, you get a full sky of stars. It was a bit of the inspiration for the Puffer Constellation project. You kind of forget if you're in cities for long enough, right? You forget what that's like. Um, and it's kind of sad that we like blotted out the night sky in a lot of the world. Yeah, California's in like SF or LA. Even I'm in Palo Alto for the summer typically, and it's still like better. It's a suburb, but it's not like remote. You still have loud, annoying neighbors and like things bothering you. It's peace and quiet is very important. This type of work. World models. I have a very long thing with world models. Nicholas, the quick version is that a lot of the best like supporting work on world models is aggressively bad science, and they are nowhere near as stable or consistent or general as they are typically presented, and they're guaranteed slow. And I'm generally, it's maybe the most promising area that I'm choosing to completely ignore in my own work, but I think I feel good about my decision to just completely ignore them for the time being. What the heck happened here? So this is advantage. How the heck is this loss different then? Because the loss is literally just this. Advantage normalized, right? Hang on. Advantage normalized. Right? Do I want to do dot mean instead? Let's change all of these to dot means. Efficient storage devices. Uh, well, they're fuzzy. They're fuzzy storage devices. So that means you're not going to have them ever subsume like non-fuzzy storage. But yeah, that's essentially what you're using them for a lot of the time, right? It's like fuzzy docs lookup because the documents are not like the documentation out there is really shit. So this is like fuzzy encoding of docs plus whatever public source code is out there that uses specific library, right? And it is literally it's a compression objective, right? That you're maximizing. And this should be good. We're gonna fix this bug today. The one thing I don't know about is muon. because we don't have Muon yet in Torch, but apparently it's getting PR'd. So if we can just use the Torch version of Muon and it's good, that would make my life a lot easier. Okay, this is solid. Yeah? Oops. What area is most interesting, promising at the moment? The problem is they're not really areas of research that have anything active going on in them. So can I just say Puffer because it's the stuff we're doing here? It's mostly stuff that revolves around high-performance sim and new ways to leverage high-performance sim. Muon's an optimizer. It's one of the additions that we have we use in Puffer 3, and it's dramatically just better than Atom. It really makes like a step change difference. It's one of the few times that in like the last several years in research, I'm willing to admit that I was just completely wrong about something. I thought optimizer research was a waste of time, and then Muon is just like a clear-cut better on everything win. Yeah, it's a drop-in replacement for Atom. It's being used on a lot of LMs, and then the only thing I can take credit for is I was the first person to really figure out that it's good for RL. That's the only thing I can take credit for. And it was really nothing impressive as much as it was just Puffer was really, really fast, so I could run a ton of experiments, and I got comprehensive results on Muon first because of that. But yeah, Muon was a really good chunk of Puffer 3.0. GG to me. I mean, really GG to the Muon authors. Yo, Lance, the one thing is you do have to fully retune hypers. So you may or may not see improvement until you actually retune your hypers. That was the mistake that people made where they didn't see it. They just tried to run it with the same hypers. So I reran full hyper sweeps on everything, and then it was obvious that Muon is just better. We're running 2 to 3 mil step per second distributed PPO built in house. We get 3 million steps per second on one GPU. We do have distributed support as well, and it scales to be even faster than that. Goal is going to be 10 million steps per second in the next release on one GPU, and not even a data center card. That's going to be on like a 4090 or maybe a 5090. Yeah, we're just like really making this stuff insanely fast. Oh, also, don't use vanilla PPO. Like, go check the Puffer blog post. We've made some really major algorithmic advancements to PPO. Our algorithm is similar to PPO, but qualitatively it performs way, way better with the advancements we've made. Is it like CUDA? Can you use it? Well, it runs. Our implementation is running Torch with the Torch CUDA backend, right? So like AMD is, if you can make Torch work on AMD, then sure it'll work on AMD. I think there are a couple people that do that. Multi-head. BTT, multi-head, tuned loss functions. Algorithm is custom with multi-head. When you say multi-head, you just mean like transformer base architecture? Tuned loss functions. Is this LLM stuff or is this like standard RL? So because we have our core model we have is just LSTM. LSTM based everything. Typically like 64 length segments collected. Yeah. I have not actually really seen good. I have not seen good enough evidence to switch to transformer based. I don't think it's worth the speed difference. Multiple critic heads. Why do you have multiple critic heads? Wait, why would you have multiple critic heads? Like you mean like distributional thing, like categorical value function? Mamba and S4. Yeah, I didn't see much out of SSMs. PRXL sucks. Yes, that is a good confirmation. So Lance, I'll give you a little bit of a preview. The thing that I'm considering doing next is going to be like min LSTM, because we're at the point where our implementation is so ludicrously perf optimized that is actually becoming the bottleneck. Like the really nice CUDA kernel that comes with the LSTM seq model is actually the bottleneck now. So we're thinking of doing parallelizable recurrent cells. Might even be this week. Yeah, check out some of the stuff in PufferLib. All of my stuff here is all free and open source. We do offer stuff for companies as well, but it's all free and open source regardless. Min LSTM and min GRU sucks for us. Really? When you say it sucks, did a parameter matched to LSTM do worse than just LSTM? Because that's the experiment that I need to run, is like full sweep hyperparameters, right? Parameter matched LSTM, min LSTM, min GRU, or even just compute matched. CUDA doesn't work with old GPUs. Okay, yeah, but those are potatoes, dude. Like, nobody even has those anymore. GeForce 7 is, like, that's 10 years old? That's more than 10 years. Yeah, RNNs are good. Yeah. So I guess that's the question, Lance, is, like, how much did you actually test these? Oh, yeah, 20 years old. There you go. Because we do really need some sort of parallelizable training cell at this point. It's really holding stuff back. Than some ML researchers. Try Mamba if you have the balls to optimize it. What are you like? I guess it depends what regimes you're running in, though, right? Hmm. But wait, Mamba's not. Is Mamba paralyzable training? Oh, screw that, man. World model shit. I really don't trust world model that. $30, $40 for one E7 frames. Well, this is just stupid. Are you having this work in, like, high data regime? Because this thing is just ludicrously slow. Like, that's unusably, utterly unusably slow. Paralyzable, It's still world model, though. My experience with world model-based approaches has been really shit. You say you're doing, like... Wait, our environments are very complex. 100 to 500 mils. I don't believe you need 500 mil for anything. Dota's 168 mil. Though if you want to see if you have like something that can really crush, take your algo and soda this. This is mini MMO. I have this training 500k steps per second on one GPU, so it's fast. And there's like tool usage in here. There's armor, there's weapons, there's equipment. There's a market where agents can trade with each other. 1,000 agents per world, all PCG. And this thing we get like log linear training curve over 650 billion steps. So yeah, give this thing a whirl if you want to stress test. As far as academic, things used in academic research, I'm pretty sure this is about the most complex multi-agent env out there. Not inherently a world model. Thought it says it in the frickin' title. MDP. Modifications on top of Dreamer. I'm so suspicious of this. RSSMs. Wait, how the heck do you... No, RSSMs are not parallel. Warburg AI. Oh, okay. I see. Cool. Yeah, we've done a couple things in finance. It's not our main focus at all, but you know, we've had a couple clients in finance. Cool to see RL being done here, though. I mean, it makes sense. I don't know why you would need sample efficiency here, though. I would think you can just absolutely crank synthetic data, because we've done like single GPU finance and finance model training that's over 3 million steps a second. Yeah. I'll add one piece of one vote for this to my mental model. I've just spent so much damn time on world model derivatives and nuts hasn't gone anywhere. Mamba is a transformer alternative. Oh, okay. Wait, Mamba. Which one? This is the one that I remembered, though. Which one is it? Mamba transformer. This? Oh, okay. Okay, okay. See, I remembered the other Mamba. Oh, wait, no, maybe you're right. Okay, yeah. That's 4. Selective state space. Hmm. Linear recurrence or global convolution. I guess there's so many damn questions, though, on this type of architecture. Does this still have a hidden state? It does. Okay, so I guess technically then this is still good for RL, because it has like a single hidden state. And then apparently then you can compute... I suppose this is sort of like MinGRU, where there's a parallel mode that you can train it in. And regardless, we need something with a parallel mode. It's kind of funny that we don't even need it with stuff with a parallel mode for our biggest experiments, because those have big enough batches that we don't really suffer that much. But for our smaller experiments and benchmarks, which are still important in research, we would like to have something that has this parallelism. Sequence to sequence transform. Oh wait, sequence to sequence. Alright, I'll have to look at this more. Hmm. Oh, we've got 2 options now, I suppose. I still want that ablation, though, like... Is it in the paper? Did they have it in the paper, the ablation on this? Of course, everybody says that theirs is the best. Right. And grew. They don't have comparison to just standard LSTM on here, do they? They have this. Why the heck don't they have like comparison to standard LSTM though? That's super annoying. Min LSTM have a smaller LSTM. No, if it's a smaller LSTM, man, then you're doing the comparison wrong. You would always parameter match. Wait, the way that you would run a good experiment on this, right, is you'd parameter match min LSTM to LSTM, and then you would compare the accuracy and training speed under optimized hyperparameters for each. Larger LLM models, so they scale better. Yeah, so that's not what we necessarily want, though, because... So this is my benchmark for everything, right? I was there when they were doing this. This is the best, by far, the best executed large-scale RL project. Right? This is a one-layer LSTM with 168 million parameters. Solves Dota. So whenever anybody tells me that we need to scale models, I just do not believe them. And in my own work, I've had like pretty extensive evidence showing that the scaling trends in RL are nowhere near as aggressive as they are in supervised learning, and there's theoretical and empirical evidence to back that. Maybe yeah. So what I was wanting to do, Lance, is I was wanting to do a parameter matched either GRU or LSTM, min GRU, min LSTM, and then compare that to see if I can get the same perf. I don't even care if it does better, right? But if I can just get the same training quality out of it and have it be faster, that's already a massive win. Because the thing is, we have settings where we have like very big batches and very small batches. And on the very small batches, that parallelism is going to be not just a 2x, it's going to be like a 20x speed up. You know, when we're running these big sweeps and computing scaling laws and things like that, it's a huge difference. Are people still arguing over my freaking, like, gigantic post? 26k views on a troll post. That's funny. Alright, but at least it's good to, at least it is good to know here, though, that we have... There's Mamba exists, and that's a thing to look at. So thank you for that. I would be interested to know if you said you didn't get much out of MinGRU, Min, and LSTM, what you ran. Frame stacking being a pretty decent. Did you ever ablate that? So no, we didn't really do frame stacking because we just made our LSTM implementation fast, and then there's not a reason to do it. Chess have achieved soda in the draw game benchmark. That's funny, Jess. That's funny. Alright, we do have to fix this implementation today, though I am interested in hearing about whether the that min architecture just flops somehow. All I want is it to be same perf parameter matched, and I'm very happy. And hopefully parallel scan to not be a total pain in the ass to implement. Because we need, so basically, I need to do something anyways because there isn't a good BF16 kernel for LSTM. So either I have to go get something else, which would be faster anyways, or I have to go spend my time on a BF16 kernel and then also probably get something else later anyways, right? So. Take a look. Advantage. 218, okay. Entropy, let's check entropy all the way. 2.5. Okay, entropy matches. Value loss. Value loss matches perfectly. Policy gradient. 5.7. 8.9. 1.2. Okay, yeah, so there's still mismatches, right? Been super excited for this ARP. And I have to get I have a doc that I just have to polish up and send over to you as well, Finn. Sorry for the delays on that. I'm super excited about that this stuff as well. I've just had a million things. I've had a million things. No worries, yeah. We'll get you something that you should be happy with as well. Excited to see drone stuff. Drone stuff will be cool. PG norm or PG loss and advantage norm. Do I just need more digits of this advantage to see if it's wrong? Is that literally all it is? Where's the format on this that's like really? I gotta just get myself an account on this. I've been lazy. Hang on. Just do quick for this. Simple. Print. 10 digits. Columns. Gonna scoot. We should have talk in Discord. Yep. Message me on there and yell at me here if I don't see it because friend rec notifications suck on Discord. I'd be happy to chat. Here. Do I have a notification from you somewhere? If you send me a rec, I'll accept. I get the notification now. This thing failed. Happen. Oh. And why is this just not print right? Print some stuff right. Why does it print entropy correctly? I do for entropy different. Nothing. I just did the exact same thing. Yeah. Oh wait, this is the Python print, you dummy. Hang on. Advantage normalized. Fix memory leak. Backend serial. Yeah, it does spin up ends differently. You shouldn't be using that for prod. It's for mostly for testing. But that also shouldn't cause a memory leak. So that's kind of weird. Is there a memory leak thing that I need to fix with serial? Like generally? It shouldn't be, but I guess it's possible. Don't think generally. Cool. Well, wasn't freeing shared mem yet. Makes sense. Oh, this is the C++. Wait. Hmm? Not seeing this correctly. Okay, now here we go. Advantage normalized. Yeah, here we go. So this is 10357660660. Yeah, so this advantage is still correct. Hmm. How's the policy gradient loss different? Yeah, how's this different? How did you create the fish animation to do with Blender? Nope. I paid 2 different artists. I am not that talented. He is our mascot. And if you're new around here, all the work I do is free, it's open source, there are educational materials, and there is publicly available research. Puffer.ai, you want to help me for free? Feed the Puffer a star. He eats stars. Discord if you're gonna get involved with dev, and follow an X for all the content. Back to dev, in which we attempt to figure out how it is possible that these two are mismatching in the 7th digit or whatever. Because this advantage function is the same. Like all the way 12 digits. And then PG loss is different in like 7 or 8, right? Driver env. Okay. Huh. Driver env doesn't free. That's interesting. Yeah, it's kind of annoying that we have stuff like that in the first place, right? Ironically, the memory management would be easier if we were writing the whole thing in pure C. It's the Python API that makes it a pain. Frickin' Python. I'd be very, very happy if I never had to write Python again. Let's write C. Great. A few other languages I wouldn't mind, but not C++. C++ sucks. What do we do? Because... I mean, it's not possible I messed up this clamping thing, right? Advantage normalized. Max and then dot mean, right? But if the ratio on each of these is 1, should ratio be 1? New log prob. Yeah, so this ratio is going to be 1, right? Because it's always the first update, so it's going to be 1 ratio. And then you wait by the advantage norm. So how is it possible then that these are different? Because, like, look at this, right? Advantages are the same. Same code, right? Like, exact same code. Literally exact same code. Okay, what else can we go looking for? Right here. I suppose I can print more digits of this, just to be absolutely sure. Man. Okay, now we're positive that these are exactly the same, right? Like, look, it's all the way matching. And then somehow, even though ratio new is here, these are 1 exactly. Then somehow, even though these ratios match, the policy gradient loss, it gets off in like down here-ish. Like the 8th digit. But like how? Right, if the inputs are the same, What's clip coefficient represented as? It's a double. Let's ask an LLM time. It could technically be like Python floating point representation. That'd be so weird though. It'd be so weird. It's gonna be some like weird Python thing, isn't it? Maybe some weird Python thing. We shall see. But my bet is on some like weird numerical representation bullshit. Which is annoying because I actually have to consider that just as seriously as normal error doing this check. And alright, so here's our loss. Go check. 8. And take. My bet is on numerical representation of clip coefficient being different in Python. Let me just set this to, let me get the last couple digits. Sure. Have an idea? Cool. We have. Send me a. So now we have the entire thing. 1, 3, 9. Yeah, so this is like the exact thing. Let me try one other thing real quick just to be sure. This will be pretty easy. If I just do like this. Because then I can just do like, right? If the hypothesis is it's like some very stupid small numerical difference in clamp. What? What you sent me? Huh? Uh, kind of. I haven't been particularly up on this area of research, though. I think Jeff Clune has a few things, Maestro or whatever. No, there's not a term for it. They're just some works. But the problem is the LLM is so much slower than the not LLM that, like, yeah, oh. Okay, so is the policy gradient loss still different here? Okay, if so, this was a good test to run. The gradient loss is 6. Wait, whoa, it's still different? 9. How is this still different? Advantage is the same. And then the ratio is the same. And the loss comes out different? Really? This... How can these possibly come out different, right? Everything else is matching so perfectly. They both have 1e minus 8 on them. Same functions. Yeah, it would be like every 10K steps could be every several episodes though, right? And then how do you actually use that guidance effectively? It's tough. Hmm. I'm a lot more confident in us just being able to crush RL the way I'm working on it now. You know? Okay, so it's exactly 1. I mean, that just seems so weird to me. Right? That we have Vantage matching perfectly. Everything else matches friggin' perfectly as well. And then the loss is off. Value loss. All the way out in digits. Vantage. And all the way out in digits. Right? Yeah, all the way out in digits. And policy gradient is actually, it's off like double precision. It is double, isn't it? I wonder what the actually output of advantage is here. This could technically be it, right? Because we advantage normalized. Zeros like values. No, but you shouldn't have to have it in double. It should be in float. So bizarre that it's like identical up to then. We have no problems with numerics at all, right? Like, we got entropy here. Exactly the same. 100 digits. Log prob. Advantage is the same. I guess wait, what is the mean advantage? How is that different? Wait. Hmm? Because we have advantage normalized. Dot mean. How are these not the same? Oh, wait, hang on. These are the same, and they should be, right? Okay. This is a clue. Listen here. 6004 1389. Oh, okay, so in the Python case, look at this. In the Python case, these two are different. These shouldn't be different, right? Yeah, these shouldn't be different. Ooh, the ratio is slightly off, you see? Yeah, the ratio is just slightly off. Barely. Yeah, it probably is like floating point, but the idea is that the numeric should be identical because we're calling TorchLib either way. So we shouldn't, like, it should be identical. Interesting. It's out to so many digits. Okay, so why is this different then? Here, and then here. Not. Try ratio. I'm try min ratio. Okay. So this is the same. Hmm. Did not get updated. Super weird, no? Go away, bot. Go away. It's not. And then this one. Went like this. Chess is hard. Let's see chess. What'd you just DM me? Do I have DMs for you? Up DMs. Okay. Well, I didn't see any of your DMs before because of Discord's DM system. Games run longer. Is this versus a random or what is this? Is this versus random opponent, Jess, or versus one step? Eh. Interesting. Okay, let me see. Versus random. No valid moves. What does the what reward does it get on a draw? And are you setting terminals? Where's the code for this, man? There are a lot of things that could be happening here. Yeah, that's completely wrong, right? It's actually learning rate. Send you code sometime. Sounds good. Ridiculous. I don't know how you even get the assets in an hour for that. Okay, so like even possible for that to be after one learning rate step. Oh one. This is 02. Hmm. So weird. So incredibly weird. One second. All right, more coffee. Um, it's very weird how this is like affecting updates, right? It's like very, very weird how this affects updates. You get like 0.02 basically. I'm assuming there's a factor of 2 on Atom somewhere, but how? Yeah, we'll try a couple other things here. I want to see if it learns first. So basically, I want to see if this is something that's like pedantic, or if this is something that's completely screwing it up and like we're just not catching correctly. But we really need this test either way, man. Saw you were. Hang on, let me read that in a second. Wow. Oops. How's your experience there? I just did an internship and not great, frankly. Really not great. I mean, the guy who brought me on was cool, but like there were just a lot of really unmotivated people that just kind of wanted to skate by and basically made it impossible to do any real work. Hell off the Neo robot, 50 cents per hour per robot. You could probably make more than that. Amazon never known for real work. That's not true. Just AWS isn't. Like, actually, not even AWS. Chunks of that are even fine. It's just the AI stuff that isn't. Like, the core Amazon warehouse business is kind of awesome, if you think about it. Yeah, honestly, I don't think I've ever been as depressed as working there. Yeah, it's just... It's very easy to put even a good engineer in a position where you just literally can't do anything, and it feels awful. Yeah, the logistics work would actually be cool. I have no doubts that there are like some actually really smart people on logistics there. That type of stuff would be really cool. I mean, all the large companies, right? There's not a single large company where you can just pick a random team and go to get a good experience. There simply are not that many talented, motivated people out there. I mean, I speak incredibly highly of OpenAI when I was there when it was like really small, but I highly doubt it's the same level of talent density today, simply on the basis of there can't be that many people that are that good. Dematic makes similar stuff. Oh yeah, we'd be down to do logistics, absolutely. We'd be totally down to do logistics. The heck is this? The heck? Situation is quite bad. What do you mean, the... What, the logistics, or what? It's 4.5 here, right? With all the perf debugging on. But then how... Yeah, what's going on with this thing? Something broke. Okay. Perf is 0, score is -1, so something's broken. Kind of struggle in creating a simple embedding based bond with no shit. Yeah. No, I believe that. I don't think I've ever seen any particularly impressive AI work out of Amazon, frankly. But I mean the logistic stuff they do, right? I don't mean like the suggestion, the Rexis on Amazon. God no. I mean like the actual logistics of moving packages around, right? Like the physical warehousing. Like that shit's hard. Don't you think? Ah, stupid. Very, very stupid. I got it. Yeah, I get it here. I think I found the bug, guys. Okay. Okay, we get this mismatch still, unfortunately. A little different, though. Yeah. What did we just get out of this? No perf. Still not training. Oh, it's going up, though. Just like... Oh, message. I have a bunch of applied scientist friends over at Amazon. They also feel they're doing very bad work. Logistics is great. They're stuck in solving problems for business, never doing creative research. And finish their task. Yeah, absolutely. That's what I would expect. It's not really the place for that, you know? Like, honestly, if you're smart and have, like, enough cash in the bank to be comfortable for a bit, the fun thing to do these days is just to figure something out yourself. It's, like, never been easier to do that. This 6 mil. Better not be faster than friggin' Python. Something's weird there. Oh, because we have... Oh, that's correct. Hmm. Hmm. Doing leverage bets in markets. Just gambling in order to feel something. Yeah, building your own stuff is a lot of fun. I particularly like the idea of just trying to build something that's very cool and unique and meaningful, and then like not getting too tied up in the traditional business. Oh, and of yes, yes, I have seen that. Funny enough, there's uh there's an announcement with that soon. Actually, I think that yeah, I have permission to say this. So we have like a very very simple simulator we built with them that we have permission to release that I just haven't gotten around to releasing. Only a very simple one though is like released public. Oh. Interesting. Why is this not trained anymore? Is it just Adam? It would seem weird that this doesn't train anymore. Oh wait, this is... Oh, this is correct. Did I break the LSTM? I probably broke the LSTM, right? Yeah, Sarvesh. Yeah, I can say that because we have authorization to release the sim. I can't say anything else though. On details. Other than, you know, Puffer does. Um, like the main thing that we do professionally is high performance simulation development, right? For RL. We also do like priority service. We do contracted R&D. Well, the main thing we do is build sims these days. I mean, it makes sense, right? Like, nobody else builds fast sims like we do. There just are 0 other people that do this. Because, like, you need the puffer stack to make, to take advantage of them properly anyways. Feed the puffer. This is, like, weird. Break the LSTM, maybe? Oh. Well, that'll do it. Wait, but then we have 2 fords. What? We do this? Encode. Decode. Hmm. Is it really, like... Is it broken? No. Brains. Oh, hang on. I remember, guys. But now it's worse. That's weird. And not being able to solve this is very bad. It's a very simple env. Yeah. What's happened here? Okay, it's better. Yeah, it's not doing the same thing. Should be. Not doing the same thing. And seg faults. Ugh. You don't want to build with debug 1, you just want to build like this. Probably end bugs. I'm gonna end stream pretty soon though, guys. I have to work on this a little offline. Couple client things as well. It's really annoying how fiddly this is. It works now in Python. Well enough at least. This one just doesn't. Big fault. Okay. Reset. Step log indices. Ooh. Okay. Hmm. Wait, what's this? answer. Yeah, that's good, right? Oops. Okay, so this still works the same as before. Still seg faults. Just from stepping the env, it seems. Is there a way I can get a trace? A trace on this somehow? Oh. What's this? Out of memory? Weird. Oh. Okay, so it's still seg faults. Takes up a little bit of RAM. Annoying. See if it still seg faults without the env. Okay, so the segfault's probably in the end, right? Let it finish just to be sure. Oh, it's still segfaults. That's weird. Man, that's very weird. Doesn't segfault as quick, but it's still segfaults. Hmm. How on earth could this possibly segfault? So we still get segfaults. Hmm. How? Well, I guess the next thing would be... Hang on. See which of these it's in. Okay, it actually fails an eval, not train. Interesting. I would think that would give you a warning. I'd be pretty surprised if that's what it is. Yeah, it's just gonna take some time, I think, to get this port fully settled. What? Mm, this is an interesting take from Carmack. Hmm. Well, what the hell even is this reply, my guy? What is that? This is a pretty interesting take. I mean, I don't he's not referring to expensive operations here, right? I kind of tend to do the exact opposite of this, right? And the lower level I go, the more I do the exact opposite of this. Hmm. I'd basically ignore that take if it were from anybody but Carmack, so I'll have to think about that. It's still seg faults for now, though. Maybe it's this. You're just not allowed to mess with the rewards tensor because it's part of the env. That would seem weird to me, though. Oh, still seg faults. Okay. Process of elimination. Yeah, honestly, most of my ops are modifying structs in place, right? Okay, so is it one of these copies being weird? That would make sense. Bob's buffer. Ah, you know, is it this? Bet you it's this. Make sure. I'm gonna try this, see if this fixes bug. Do my first deadlift set, and then I'm gonna end stream if nobody has questions. Don't seg fault. Don't do it. Ah, still seg faults. Dang. Oh, you know what? Hang on. These come from here now. These buffer types. Okay, because this one is the type. And then these are all floats. mouse. Pretty weird. Pretty weird. Wow. I'm gonna have to figure this out. But I got some stuff to go do. So I'm gonna call it on stream for a bit, guys. Man, debugging this stuff takes some time. Alright. All my stuff's on puffer.ai. You wanna support my work for free, start at the GitHub. Join Discord to get involved with dev. You can follow me on X for more RL content. I'm gonna see if I can figure this out throughout this afternoon. And yeah, I will be back for a little stream